Hey, this is Chris at Art Secret Studio, and I want to share what glazing is. Glazing is when you take either semi-precious stones or minerals or rocks or whatever it is, and these big chunks of whatever it is, or maybe it's dirt like the Georgia clay, which we don't make paint out of. Maybe it's dirt, and you take these and you grind it up. And the size of the grind, we're going to call flakes, determines whether you can glaze with it. Imagine taking a clear glaze, and I take a clear glaze and I put it in this little silver cup. It's a mixture of Galkit and Stand Oil. It's 80% Galkit, 20% Stand Oil. Stir it well. Do not pre-mix. Galkit dries like concrete underwater. So I only mix what I need each day, and that's it. You've taken this particle and you've ground it up and you've made this rock. And then in this container of oil, if I put these rocks in this oil, if I have enough rocks in that oil, is it like dripping? If I have enough rocks in this oil, you can't see through it. So if these rocks are big chunky rocks like this, and there's enough of them, then your eye cannot see through the oil, and you just see chunky rocks. That's called an opaque color. But if the rocks are smaller, and I put a clear fluid in there, just kind of clear, because there's red on my brush. If I put a clear fluid in there, whatever color those rocks are, and you can see through it, that's a semi-transparent color. Now, if the rocks are tiny, and you can see all the way through with these little tiny red marks and these flakes everywhere, or nothing but tiny red flakes, and you can see completely through it, that's called transparent. So transparent paint isn't actually where it's like food coloring and it dissolves completely. Everything's made of atoms. There's particles in everything. It's never gone. So a transparent color just means the grinding of the rock. Can I get you to hold this? No, I'm joking. The grinding of the rock is so small that we don't really see it. And you have all this oil that's suspended in, and you see through and in between the fine particles. Okay? So when you look at the paint tubes, you see paint tubes are sort of like this. I've seen a chart before. There's the cover of the paint tube. There's the neck of the paint tube. Well, this is an old paint tube from 1880. Most paint colors are in the area of 50 to 55% paint and 50% oil. And the percentages change slightly. 49, 48, 47, 51. And then sometimes the companies change the type of oil, or mixing the oil to maybe two types of oils. Sand oil, safflower oil, and you combo oils. What they're trying to do is to get the pigment to dry in the oils at the same time. Some colors take longer to dry than others. Okay, and they're going to try to make them all dry relatively close, though alizarin seems to be one that never dries. Okay, so here's what happens with glaze. So what happens with glaze is light comes through. When I take this and I dip it in my glaze and I take some alizarin and I fill this whole thing with alizarin right here, and then that dries, it forms like a sheet of plexiglass. And then when I go over it with another color like yellow, and my yellow has some red in it, so it might not be pure yellow. So I take some yellow, okay, in the area, so my eye sees through the first sheet of plexiglass. Now when it dries, it sees through the second sheet of plexiglass. And that means yellow and red make orange. Optically for my eye. So some parts that it's not overlapping, I see alizarin. Some parts where it's not overlapping, I see yellow. And some parts where it is overlapping, I see orange. That's why a lot of times I don't mix violet. I use alizarin in some parts and cobalt in some parts to bring activity to an area. And then where they mix, it makes purple. But that means when it dries and next time I go over it, I see, oh yeah, I got alizarin there. I'm going to leave some of that alizarin and I'm going to do a little cobalt to the left or to the right and I leave some of that. Does that make sense? Oh, the doctor said I get it. One more thing just clicked, right? Each day, each week you've had a huge victory. It's been a good month. Are you sleeping longer? Are you getting a nap? What's the deal? It's bizarre. And you're making this hour and 40-minute drive. How did Megan make her 4-hour drive from Augusta every week? Oh yeah, well, she stayed for 2-3 classes and visit with her mom, yeah, but still, that was a haul. Okay, so then that dries, and I'm gonna try another color. How about Manganese Blue Hue by Winsor Newton? I absolutely love it. There's a little yellow on my brush. And then over the yellow area, it makes green. But if I saw the red in that area and the red over this might make a different color. Do you know what I mean? Now, because orange and blue make gray. So every time you make a new sheet of plexiglass, you have to think in combos. I already have yellow and I have red, that made orange. Now I'm going to add blue, what does that make? So sometimes when I'm painting a portrait, I know that glazing with cobalt can make something, if something's too red and I'm going to glaze it with cobalt, it'll make it purple. And I want it grayer on the face. So there's been times I've warmed up the red to make it more orange, because cobalt and orange are complements. So then knowing next week I'm going to glaze cobalt over it and that'll make it grayer. So sometimes when I glaze, I alter the color to change something for tomorrow. And if I'm just blocking in, I'm not thinking like that. You know what I mean? There's a plan here. Because here's the plan with glaze. You get how many chances? 1. The whole room put up 1 finger. 1. This is planned. So when I'm painting the pelican, and I said, you know, I think I'm going to glaze some color on the white here. I'm going to say which color before we do it. We need to talk. Because you get 1 chance. Gosh, and this class was supposed to be fun. Right, Teresa? Fun. Yeah, yeah. When my nephew's wife was pregnant, and I said, hey, last chance to go fly fishing. He said, I think that boat sailed, or that ship sailed long ago. This little kid comes running to hold him. Okay, so if I do another layer, pick one, we'll say Viridian. These are all transparent colors. Now, Viridian and blue, not going to see much difference. It'll be a hint of a blue-green color, you know. But if any of these picked it up, or, you know, I'm going to leave that mess alone. So glaze, so what happens with the particle size? Well, why don't they just grind everything up to be small and make everything transparent? That was Margaret's question earlier. And what happens is each pigment vibrates at a certain frequency. And that frequency, each pigment is the most beautiful when the pigment is a certain ground size. So when a rock is a certain size, it's more beautiful. If I make it smaller, it could have less reflective index color coming back. So what they do is they look for each thing they're going to make a pigment color out of. And they say, at what size is it the most beautiful? So cadmium red is a very large pigment. And it's beautiful ground to this size. They don't see a need to make it transparent. They just want that color to fill a need, and I need cad red. And it does it beautifully, but its pigment is large and therefore it's opaque. So I can't glaze with cad red. And if they grind it small that I could glaze with it, the color becomes so ugly, we're not buying it. So there has to be a cost and a reason they're choosing why they grind pigments a certain size. And I'm thinking it's out of beauty, but it could be out of financial, it could be any reason that I'm oblivious to. Does that make sense? So that's how that works. So now, how does this work? Let's take this a step farther.